we want to take our time to start with the component capacitor. Capacitor. What is a capacitor? A capacitor is just a device for storing charges. If you have read about a cell, the definition of cell, you might get it confused with this same definition. But the difference is that a cell stores energy with the idea of chemical energy. But a capacitor has its own setup for storing energy. It is not due to chemical energy. It just consists of two conductors that are charged. Those two conductors separated by distance or by an insulator. Capacitor quickly stores charge and quickly gives out its charge if discharged. That is the usefulness of a capacitor. That is what they put to use in using a capacitor. A capacitor is a device for storing charge. It consists of two conductor plates, this and this, separated by a distance. Or you can choose to put an insulator here. That is just the conductor or the wires connected to the capacitor. Now if you place an insulating material here, that insulating material between those two plates of the capacitor is what we call dielectric substance. This insulator will not choose to place it between the plates, the two conductors, is what we call dielectric substance. Now in image, a capacitor is given this way. Anytime you see this in physics or schematic diagram of electricity, it represents a capacitor. Look at these two lines, they are of equal size. When one represents the battery, you notice that one line is longer than the other. This is a cell, while this is a capacitor. Capacitor and cell. So you note the difference. The capacitor is represented this way, a symbol in the circuit. Now to charge a capacitor, you just bring your two plates, your two conductors, you connect it to a power source. Let's say it is a cell or a battery. This is the battery. Now how does this work? Electrons from the negative terminal of the cell flows to this place, and then that becomes filled with what? Negative charge. Negative charge. I've never said that electrons possess negative charge. As electrons are flowing from the negative part terminal of the cell to this place of the capacitor, electrons are also leaving the other place. Electrons are leaving from the cell negative part of the cell to this place, while electrons are not leaving from this terminal of the capacitor to this cell. So because this place is losing electrons, let me claim the insulator. Because this place are not losing electrons, it will not have excess proton. Because in any atom, in any conductor that is stable, that is neutral, number of electrons is equal to the number of proton. Now that this state is losing electrons, now excess proton will now become positively charged. Now this goes on and on and on. And as it's going on, this process is getting slower and slower. And when it gets to a point, because this plate is negatively charged, this plate is positive charged, there is not a potential difference. There is not an electric difference between these two plates. Now once the potential difference in this plate becomes equal to the potential difference of the cell, the capacitor will stop charging.